So this was your assignment yesterday, and let's answer. Let's see whether you had submitted the correct answer for this. Now, what is our problem? How many grams of sodium chloride are contained in 100 ml of a 0.200 molar solution? So this one is for molarity. Let's go back to our formula. Molarity is equal to moles of the solute divided by liters of solution. And if we look at the problem, we have the given here for the molarity 0.200 molar. And then we have here the volume 100 ml. We just need to convert this to liters. And the mole is not given in the problem. But what is asked in the problem is the grams of our solute, which is sodium chloride. So if we are going to start, we will be looking for the moles first. We will be substituting the given here in our formula, 0.200 molar. And instead of capital letter M, it will be more appropriate to use moles per liter here so that we can clearly cancel the units. Okay, and then again, we are looking for the mole first. And then the liters, yung 100 ml, 100.0 ml, we'll convert this into liter using the conversion factor. In 1 liter, we have 1,000 ml. So make sure that the other one is on top, the other one is below so that we can cancel. Okay, let me just get first my calculator para diretso-diretso tayo. 100 divided by 1,000 is 0.1 liters. So we will be using that here. We can cross multiply this. I did not derive the formula. I just substituted the given and just go with the process. So we will be having the moles here on the left side. On the right side, you will have 0.200 moles per liter times the 0.1 liters, wherein we can cancel the liters, we will be left with moles. So 0.1 times 0.200 is 0.02 moles. Okay, so this is now the moles of our sodium chloride. However, we are looking for the weight in grams. So we will be using another formula. Mole is equal to the weight of our sample divided by its molar mass. The mole is already computed, 0.02. We will look for the weight of the sample. And then for the molar mass, we just need to compute this. So our sample here is NaCl, 1 atom for each element. And then multiply to their respective atomic weights in whole number. So this is 23, this is 35. So our molar mass here is 58 grams per mole. Do not forget the unit, 58 grams per mole. Excuse me. Now, let's have the cross multiplication also with this. So on the left side, you will have weight of the sample. And then on the right side, 0.02 mole times the 58 grams per mole. So as you can see, we can cancel the mole. The unit that is to be left will be the grams. So 0.02 times 58 is 1.16. So this is the correct answer for the assignment yesterday. I hope you got this, the 1.16. So please be familiar with the process. If you are asked to compute the grams of the solute, start first in computing the moles. And when you get the moles, you can use that in computing the weight of the sample in grams. So do not forget to ensure that the volume should be in liter first. You cannot cancel the unit if the volume is not converted into liters. And do not forget the process of computing the molar mass. For us to be uniform, you have to round off the atomic weights to the nearest whole number. Any question for the assignment? Wala. Nakuha naman na ito. Okay. So I hope everyone has already submitted their assignment. Ay, naghang siguro akong laptop. Ano siya? Wait lang. Oh, it's okay if you have a different solution as long as you got the correct answer. No problem. Loading pa rin. Sige. I think meron tayong correction sa ginawa nating computation yesterday. What was that, Danica? Si Danica yun, no? Ito yun, di ba? Tama ba?
Yes po, ma'am.
Okay. Ulitin natin siya compute para mas klaro sa inyo. So this one is calculate the amount in grams of zinc chloride in 1,300 ml of 2.3 molal zinc chloride solution and the specific gravity of our zinc chloride is 2.9. Again, our given here, we have the volume of solution in ml, and then we have the molality of the solution, that is 2.3 molal, and then the specific gravity, which is 2.9. Now, what is asked in the problem is the amount in grams of our zinc chloride. Okay, so remember our formula for molality is small letter m equal to moles of the solute, but divided by the kilograms of our solvent. So it's just like the computation just a while ago. We need to compute for the amount in grams. So the first thing that we need to do is to compute for the moles first. The molality is given, that's 2.3. Now to really cancel the unit, let's just use moles per kilogram. Again, we are looking for the number of moles. However, for molality, we should use the kilograms of the solvent, but the given here is 1,300 ml. Now, since this is not a pure water, then we cannot use yung tinuro ko sa inyo kahapon na 1 gram is equivalent to 1 ml. So that's the use now of the specific gravity. So do not forget, class, yung specific gravity is equal to the density of the substance divided by the density of the reference standard, and this is mostly water. So, i-compute natin siya, 2.9, itong specific gravity, we will be needing the density of the substance. And then I told you yesterday, the density of water is constant, that's 1.0 grams per ml. Okay? And then we will be doing cross multiplication. Therefore, on the left side, we have the density of the substance. On the other side, you will have 2.9 times 1.0 grams per ml. So the density here of our zinc chloride is 2.9 grams per ml. However, we are not yet done kasi our goal is to look for the kilograms of our solvent. And dyan papasok yung density. So do not forget our formula for density. Density is equal to mass over volume. Ang na-compute natin na density is 2.9 grams per ml. We are looking for the mass. Remember, our goal is to convert 1,300 ml to kilograms. So the volume here is 1,300 ml. This is for the zinc chloride. So magko-cross multiply ka, you will have here the mass is equal to 2.9 grams per ml times 1,300 ml. Cancel the ml, ang maiiwan ay grams. So 2.9 times 1,300 is 3,770 grams. Okay? Pero mahaba-haba ito na computation because again, we are going to use kilograms. So you have to convert the 3,770 grams first into kilograms. Our conversion factor in 1 kilogram, we have 1,000 grams. So sa ilalim siya so that we can cancel the unit. So 3,770 grams divided by 1,000 is 3.77 kilograms. I hope nasundan pa yung ating computation. So since meron na tayong kilograms of our solvent, let's substitute that one here. And then let's do the cross multiplication again. Ibaba natin si mole. You have here 2.3 moles per kilogram times the 3.77 kilograms. So we can cancel the kilograms, class. The mole here is 2.3 times 3.77 is 8.671 mole. Dito ata nagkamali. Tama ba? Dito, no? Hindi ko kasi maalala saan nagkamali yung computation. So 2.3 times 3.77, that's 8.671 mole. Yan yung gagamitin natin in the computation. So balikan natin yung formula. Mole is equal to the weight of the sample divided by its molar mass. So this is 8.671 mole. And then the weight of the sample here. And then for the molar mass, this is zinc chloride. Dito ko lang siya ilagay sa gitna. Zinc chloride, class, is ZnCl2. So you have 1 atom of zinc, 2 atoms of chlorine. Ilan nga yung atomic weight ng zinc natin? Nakalimutan ko na.
65 po.
65 na.
65. Okay, so this is 65. So let's add. This is 135 grams per mole. So yan yung gagamitin natin here. Let's do cross multiplication again. So the weight of the sample is equal to 8.671 mole times 135 grams per mole. So let us cancel the mole. Ang maiiwan is gram. So 135 times 8.671 is 1,170.59. Let's round it off to the nearest 2 decimal places. So ito yung weight of our sample, 1,170.59 grams is needed to be dissolved in 1,300 ml of water for us to have a 2.3 molar zinc chloride solution. Yes, very, very mahaba yung ating computation for this. And this is included in your exam. Tapos, I think yung exam natin nito is show your solution. So before mag-start ang exam, dapat ready na lahat. Ready na yung calculators ninyo, yung inyong periodic table, yung paper ninyo, and even your cell phones that will be used in taking photo of your answer. Wala yung shortcut. Wala siya shortcut. Actually, if ako yung nagko-compute nito, hindi ko na siya actually hindi na ako nagko-compute ng density of the substance. Automatic kasi yun. If for example, the specific gravity is 2.9, automatic yung density niya is 2.9 grams per ml. So most of the time, pag nagko-compute ako, dito na ako na part, magsa-start. Dito na ako. I don't compute this anymore actually. But for the sake na alam nyo saan galing yung density ng substance, kaya pinakita ko siya sa inyo. Kasi multiply mo lang naman siya sa 1. Pero magkakaroon na siya ng unit, that is grams per ml. So dito na ako nagsa-start if I am the one doing the problem. Sa exam, hanggang nakabox lang na answer. Sa exam ha. Pero we are not yet done making the exam. Kasi yung exam natin, similar with the other sections, So I need to collate first the questions coming from the teacher from the other sections before ko yun matapos yung exam. Okay? Wait lang. Yeah, you can skip that during the exam. I mean the part wherein you have to compute for the density of the substance using the specific gravity. You can actually skip that during the exam. Kasi automatic talaga yun siya, class. If ang binigay is the specific gravity is 5.6, the density will be 5.6 grams per ml. So to save more time, okay lang sa akin i-skip nyo yun siya. Okay. Let's have the assignment. What was the assignment nga? Kalimutan ko yung question. How many? Sulat ko lang kasi yung kapon. Yan. Let's have a whiteboard and let's solve your assignment. Okay na, nakapasa na ba lahat? Baka may hindi pa nakapasa. Okay, let me rewrite the question on the screen. How many grams of NaOH is required to make 2,500 ml of 0.25 molar NaOH solution. So the specific gravity of our NaOH is 1.52. Okay? Ito yung ating problem for your assignment. Actually, this really happens in the laboratory. Like you will be asked to make a certain solution, for example, sodium hydroxide. Tapos dapat ang concentration niya 0.25 molar. And then ang volume dapat niya is 2,500 ml. So yun yung requirement na gagawin mo na solution. Pero bibigyan ka nito ng sodium hydroxide na pellets. So solid yan siya. So ikaw ngayon yung magde-decide paano mo siya gagawin. So sa laboratory, yung laboratory in charge, nagko-compute talaga nito kung gaano karaming sodium hydroxide, for example, yung gagamitin niya to really prepare that certain concentration and certain volume. Now, if you will be working in a chemistry laboratory, most likely gagawin nyo din ito. Kasi I know medical technologists who are working, like example in the PDEA. So doon sila sa chemistry laboratory ng PDEA, and one of their function or one of their job is to prepare chemicals. So that is the reason why you have this subject. Okay? Pero hindi naman lahat. Mas marami yung medtech na yung ano talaga yung trabaho. Medical technologist. Ay, sorry. This is molality, no? Small letter M. Paki-correct na lang. Small letter M kasi molality pala yung ating lesson yesterday. So, hindi to capital letter M, ha? Capital letter M is molarity. Ito, small letter M, molality ito. Yan. So, again, our formula for molality, moles of our solute divided by kilograms of our solvent. The molality is given. That's 0.25. Let's make this moles per kilogram. And then the first step again, let's compute for the moles. But the kilogram is not given in the problem. Instead, it's in ml. And since this is not distilled water, we need the specific gravity. Okay, so I will just let you see the conversion of the specific gravity to the density, pero ganun pa rin naman yung answer dyan. Specific gravity is equal to the density of the substance divided by the density of water. So yung SPGR natin dito, 1.52, hahanapin natin yung sa substance, yung density of water is 1 gram per ml. So you have to do cross multiplication. The density of the substance is 1.52 times 1.0 grams per ml. So this is still 1.52 class. Magkakaroon lang siya ng unit, which is grams per ml. Now, if you have the density, you can compute na for the mass para ma-convert natin si 2,500 ml to kilograms. So yung density nito, let me delete this first. Yung density na na-compute natin, 1.52 grams per ml. We are looking for the mass. The volume is 2,500 ml. Let's do cross multiplication. The mass here is 1.52 grams per ml times 2,500 ml. Let's cancel the unit. 1.52 times 2,500 is 3,800 ml. Ay, sorry. Bakit ml? This is grams. Ayan, this is grams. And then, we need to convert the 3,800 grams to kilograms. Our conversion factor, 1 kilogram is equal to 1,000 grams. So, you cancel the grams, ang maiiwan na unit, kilograms. So, 3,800 divided by 1,000 is 3.8 kilograms. So, yan yung gagamitin natin here. Kompleto na. We can get the moles now. Let's do cross multiplication of this. This is moles is equal to 0.25 moles per kilogram times 3.8 kilograms. So let's cancel the kilograms and let's multiply. 0.25 times 3.8 is 0.95 moles. So let me recheck. Baka may na-miss ako in the process. Nalibat na sad ko. 8 times 0.25. That's 0.95 moles. But we are not yet done. Kasi in the laboratory, we don't have anything that can measure moles. That is the reason why we need to convert it into grams. So moles is equal to the weight of our sample divided by the molar mass. The mole is 0.95. We are looking for the weight of the sample. And for the molar mass, this is NaOH. So Na, oxygen, and hydrogen. One atom for each element. Our elements. And then this is 23 for sodium, 16 for oxygen, and 1 for hydrogen. So our molar mass here is 40 grams per mole. So ito yung gagamitin natin here. Let's cross multiply. You will have weight of the sample is equal to 0.95 moles times 40 grams per mole. Take note, we will cancel the mole. Ang maiiwan na unit ay grams. So 0.95 times 40. Ang correct answer here, class, is 38 grams. So I hope yan din yung sagot na sinubmit ninyo doon sa submission din for the assignment. So 38 grams. Now, pag sa laboratory ito, class, all you need to do is weigh 38 grams of the sodium hydroxide na pellet and then dissolve it in 2,500 ml and magagawa mo na yung solution na ang kanyang concentration ay 0.25 molal. So, ganun siya. Actually, mas madali siya gawin, mas mahaba yung kanyang computation. Kasi pag alam mo na kung gaano karaming substance ang kailangan mo, diretso mo na kasi siya dissolve hanggang maging 2,500 ml siya. And then automatic yung kanyang concentration is this one, 0.25. So, any question regarding the assignment or clarification? Molality yan ha, be careful. Be careful during the computation sa exam or sa quiz. Kulang ko ng isang quiz sa inyo. After exam na lang yon. Be careful if molarity ba or molality yung binigay. Okay? No question? Sure na? So let's move on. Let's move on. This is the third unit of concentration. And this is a bit more complicated compared to molarity and molality. So please listen. Baka mawala kayo during the computation. So again, this is normality. And we use the symbol capital letter N for the unit. So minsan ang makikita niyo dito is number ng concentration, example 0.5 and then capital letter N. If that is capital letter N, that is normality. Okay? Or we call this normal. So example 0.5 normal hydrochloric acid. Yan yung kanyang concentration. Now, for normality, normality class is actually expressed as gram equivalent weight of solute per liter of solution. Again, gram equivalent weight siya ng solute pero over liter of solution. So before you can compute for this expression of concentration, we have to get the equivalence factor first. I'll be teaching you that later. Now, what is our formula? Normality is computed as equivalent per liter. Take note, marami kasi siyang formula. So take note of the formula for the normality. Either normality is equal to equivalent weight, equivalent weight per liter. Pwede din siyang normality is equal to milli-equivalent weight per ml. If the volume that is given is in ml, we have to use the milli-equivalent weight. Okay? Or we can simply use normality is the weight of sample. This is in grams divided by the volume in ml times the milli-equivalent weight. Marami tayong formula. Pakikopya na lang muna yung formula natin. Or pwede din, normality is equal to weight in grams divided by volume, this time in liters, times the equivalent weight. So yung tandaan nyo lang, kapag ang volume is in ml, ang partner niya ay milli-equivalent weight. Pero pag liters, ang partner niya ay equivalent weight. Okay? Diba ako? Okay, pakikopya yan. Medyo mahaba. Medyo marami. And then we are not yet done. Kasi, inside the laboratory, we also don't have any instrument that can measure equivalent weight and milli-equivalent weight. So, meron din silang formula. If we are going to compute, wait, let me correct that. That should be capital letter E. If we are going to compute for the equivalent weight, meron din tayong formula for this. So, let's be patient. Let's be patient with this class. Yung ating formula Equivalent weight is equal to the molar mass divided by the F. The F class is called the equivalence factor. Okay? Later, I will also teach you how to determine the equivalence factor. So, mo ni siya kung giingon, kagaina na normality is a bit more complicated. Actually, way more complicated compared to molarity and molality. And if you're going to compute for the milli-equivalent weight, this is molar mass divided by F times 1,000. Okay? Introduce muna natin lahat ng formula for this. Okay? Before you can compute for the normality, daghan kayo kag agian. Okay? Okay lang sana kung binigay sa problem automatically yung equivalent and then yung milli-equivalent weight. And then divide mo na lang siya automatic sa volume. Pero kung hindi, kailangan talaga natin siyang i-compute class. Okay? Sige, I hope na nasulat na yung formula natin na napakarami. And then let's move on. So let's have automatically the problem solving. Ito yung ginagawa sa laboratory. Find the normality of this substance. Ang substance natin, sodium carbonate. Yung amount niya is 0.321 grams. And then, dinisolve daw siya sa 250 ml na solution. Again, magko-compute tayo ng normality. Marami akong binigay na formula for normality, but since equivalent and milli-equivalent weights are not given in the problem, therefore you have to use the formula na gagamit ng weight of the sample in grams. Okay, you use this formula. You have to look at the given first. Again, the given here is the weight in grams, so ito yung gagamitin ninyo. Not the one na diretsong equivalent or milli-equivalent weight divided by the volume. Now, this one is divided by the volume, pero take note that the given is in ml. Okay, the given is in ml times, ano nga ang partner ng ml? Equivalent weight or milli-equivalent weight?
Milli-equivalent weight po,
Okay,
ma'am.
milli-equivalent weight yung partner niya. So, di ba, the weight of the sample is given, that's 0.321 grams divided by the volume in ml, 250 ml. Yung problem na lang natin dito, class, hindi given si milli-equivalent weight. So, we cannot proceed with the computation. So, I have given you the formula for the milli-equivalent weight. This is molar mass divided by the F times 1,000. Okay? So, yung molar mass, this is sodium carbonate. If you're going to compute for the molar mass, you have to know the formula first. Chemical formula of sodium carbonate. This is sodium and then carbonate. Diba? Sodium is positive 2, positive 1. Wait lang. Nagdiretso na tuloy ako. Positive 1. Bakit siya positive 1? Take out your periodic table. Sodium belongs to group 1. So automatic yung kanyang charge ay positive 1. I hope you can still remember our lesson sa Chem 101 for that. Pag nasa group 1, kasama siya ni hydrogen pababa, positive 1. And if you still have a copy of your polyatomic ions, you can use that one also. Polyatomic ions. Nandyan si carbonate. So si carbonate dyan, kung titingnan ninyo, ano ang charge? Charge ni carbonate dyan sa
Negative 2 po.
negative 2. Okay, very good. Negative 2. Now, to ensure that your chemical formula is correct, kailangan pag i-add mo si positive and si negative, dapat zero siya. Pag hindi zero, we need to do cross multiplication. Hindi talaga ito zero kasi positive 1 plus negative 2. So, ang tamang chemical formula ni sodium carbonate ay Na2. Sa baba ang 2 ha kasi nag-cross multiply tayo. And this is CO3. No need to have the 1 na subscript. Kapag ka 1, hindi mo na siya ilalagay. Kaya yung carbonate, CO3 lang talaga siya. So, if we have ensured now na ito na yung correct chemical formula ni sodium carbonate, we can compute for the molar mass. So we have 3 elements here, 2 atoms of sodium, 1 for carbon, and 3 for oxygen. Let's multiply them to their respective atomic weights in whole number. This is 23. So 23 times 2 is 40. 43. 46. Wait. 46. And then this is 12. And this is 16. So this is 48. Okay. 48 plus 12 plus 46 is 106 grams per mole. So yan yung ilalagay natin dito, 106 grams per mole. Yung problema na lang natin, class, yung F. Paano ba matadetermine yung F? Please take note of this. If the substance is an acid, the F class is the number of replaceable hydrogen. Okay? Again, if the substance is an acid, the F is the number of replaceable hydrogen. Ibig sabihin yan. Example ng acid, hydrochloric acid. Ilan yung hydrogen niya? Isa. So kay isa ang hydrochloric acid, ang F niya is 1. Okay? 1. Now, another example of an acid, sulfuric acid, H2SO4. Ilan yung hydrogen niya? 2. Okay. So, since 2, ang F niya dyan, class, yung equivalence factor niya is also 2. So, kung acid, tignan mo lang kung gaano karami ang hydrogen niya, yun yung equivalence factor niya. Okay, another example, phosphoric acid. You have 3 hydrogens there, so the F here is 3. Okay, so you have to identify first what type of compound is given. If that's an acid, that's the number of replaceable hydrogen. But how about if the given is a base? The F naman is equivalent to the number of replaceable hydroxide. So kung ilan yung hydroxide niya, yun ang kanyang F. Okay? Diba? For inorganic substances, one definition of a base is meron siyang OH. So bilangin niyo lang kung ilan yung OH niya, yan yung kanyang F. So let me give you an example. NaOH, sodium hydroxide. Ilan yung OH niya? Isa. Isang OH lang yan. Counted yan as 1. So the F here is 1. Pero another example, calcium hydroxide. So makikita nyo naman siya sa subscript. The hydroxide is placed inside an open and closed parenthesis. So and then meron siyang subscript. Yan yung kanyang number of replaceable hydroxide. So for calcium hydroxide, this is 2. So automatic, the F is 2. Okay? That's how you know for the base. Now, pag hindi siya pumasok sa acid, hindi din siya base, ang tawag natin dyan, salt. Okay? Kung walang hydrogen, kung walang hydroxide, we call that salt. So kagaya ng sodium carbonate, in our problem, wala siyang hydrogen, wala din siyang OH. So dito siya mahuhulog, class, sa salt. Now, paano natin malalaman yung F ni salt. The F class is the total, take note, total, positive, and take note of the word or ha, hindi and, meaning either the positive or the negative charge. Okay? Yan yung sa salt. Total, we need to total either the positive or the negative charge for the salt, and that will be the F. So bigyan ko kayo ng example. One example before natin i-compute si sodium carbonate. One example of a salt, yung pinaka-common is sodium chloride. We don't have a hydrogen here. We don't also have an OH. So salt talaga siya. Paano natin malalaman? You go back to the charges. Please take out your periodic table or your list for the polyatomic ions. Sodium belongs to group 1. So ang charge nito class ay
1.
positive 1. Okay. And how about chloride? Chloride belongs to, if we are going to...
Negative 1 po.
Okay, very good. So let me draw a periodic table. Siyempre, hindi ko lalagay lahat ng elements dyan. Ay, wait lang. Mali ito. Kailangan magpantay sila on the other side. Okay. So example, this is your periodic table class. You have hydrogen here. You have here the beryllium, carbon, nitrogen, oxygen, boron. Boron, carbon, nitrogen, oxygen, fluorine, and you have the helium here. So do not forget ha, lahat ng nasa group 1A ang charge positive 1. Lahat ng nasa group 2A, beryllium pababa, positive 2. I-refresh lang natin, baka nakalimutan na. Lahat ng nasa boron group, aluminum yung nasa baba niyan, lahat sila positive 3. Si carbon, either positive 4 or negative 4. That's how unique carbon is, and that is the reason why we have organic chemistry. Nitrogen, pagdating kay nitrogen class, babalik ka sa negative 3. Okay? 3 na siya pero negative. Yung oxygen na naman pababa, negative 2. And then si fluorine pababa, negative 1. Si helium, we don't really, for noble gases, we don't really have charge for this. They have completed the octet rule. That is why they are called noble gases. They have 8 electrons in their outermost shell and they don't really combine with other elements to form a compound. Na fluorine, chlorine, bromine, iodine, makikita natin si chlorine right below fluorine. So that is negative 1. Ito, negative 1 ito. Pero, i-continue na lang natin. Lahat ng nasa dito sa gitna, transition metals yan, positive 2 yan sila, with a few exception. So just like silver is positive 1. And then we have multi-charged elements like si iron, pwede siyang positive 2, pwede din siyang positive 3. Si copper, pwede siyang positive 1, pwede din siyang positive 2. Si mercury also, positive 1 or positive 2 ito. And meron tayong exceptions here, hindi sila transition metals. Yung lead, nandito yan siya. Si lead can be positive 2 or positive 4. And so does tin. Positive 2 and positive 4 din yan siya. And yung mga exceptions to our rule. So please review on that kasi we need that in the computation of normality. Now, balikan natin si sodium. Yung kanyang charge, positive 1 or negative 1. Ang F nito class, 1. Okay? The F is 1. Take note, total, and then take note of the word or. Meaning, hindi natin sila i-add. Kailangan lang natin yung number dyan. Now, since parehas yan sila 1, automatic the F is 1. Okay? For sodium chloride. Pero, tingnan natin si sodium carbonate. Si sodium carbonate is Na2CO3. Yung Na, positive 1 yan, di ba? Yung Na, positive 1. Pero take note na meron siyang subscript na 2. Ito yung sinasabing total. So, kung dalawang positive 1, it means lahat-lahat ng positive charge ni sodium carbonate is positive 2. Nakuha yon? Bakit positive 2? Okay? Sige, si carbonate naman is, look at your list there for polyatomic ions. That's negative 2. So actually, ang compound, pantay talaga yun ng positive and negative charge. So hindi dapat kayo malito. Okay? So, kasi tingnan nyo yung subscript. Pag hindi yan sila nagpantay, tingnan nyo kung may subscript. I-multiply nyo siya. 2 times positive 1, that's positive 2. Therefore, for sodium carbonate class, the F is 2. Okay? Again, do not copy the charge anymore. You just need the number there. And that is 2. Yan yung kanyang F. Question so far, medyo mahaba talaga itong normality. Meron bang question or clarification before tayo mag-proceed? Let me delete this one here so that I'll have more space for the computation of the normality. Yung exam natin hanggang sa matapos ko lang ngayon ha, because I don't think I can finish this. So yung iba, pagpapatuloy natin sa midterm. Okay? So ano na nga? Yung ating F for sodium carbonate, that is 2. Okay? Times 1,000. By the way, merong unit yung ating equivalence factor. Ang unit niya, pag milli-equivalent weight, this is milli-equivalent per mole. Yan yung unit ng ating F. And again, this is the unit for the F, milli-equivalent per mole if we are looking for the MEQ weight. And take note that we can cancel the mole. Ang maiiwan, grams per MEQ. So, ipagpatuloy natin yung ating computation. Yeah. Oo, tama yan siya. Ano pagbasa ng pangalan mo? Ginny
May po.
Okay, Ginny May. Kung ano yung charge ng first element, ganun na din yun sa next one. Kasi pantay talaga yan siya basta compound. Okay? Now, this is 106 grams divided by 2,000 MEQ. Kinancel na natin yung mole. So, anong sagot here? 106 divided by 2,000. This is 0.053 grams per MEQ. So, meron na tayong milli-equivalent weight class. We can proceed now in the computation of normality. Lagay natin siya dito, 0.053 grams per MEQ. Okay? So, we can actually cancel the grams. Ayan. We can cancel the grams. So, magiging 0.321 ito. And then, let's multiply 250 times 0.053. This is 13.25. And take note of the unit ml. And then, per MEQ ito. Nasa baba si MEQ. And then, let's divide. Dito na lang ha, kasi wala nang space sa baba. 0.321 divided by 13.25. Kung 2 decimal places, this is 0.02. And then, ang unit ganito. Since nasa baba si ml per MEQ, pag dinivide natin yan siya, you have to get the reciprocal. When you say reciprocal, ibabaliktad mo siya. Meaning, magiging MEQ per ml na siya. Sa mathematics, ang rule natin, kapag pag-divide natin nasa baba yung unit, tapos
ml per MEQ siya, for example, you have to get the reciprocal. Meaning, kailangan mo siyang baliktarin. MEQ per ml na yan siya. Or you can just simply write 0.002 and then capital letter N. So kung taas ang computation sa molality, mas taas dyan ang computation sa normality. Just have to follow the steps. Okay? So ano nga yung first step natin? You have to compute first for the milli-equivalent weight using this formula. Pero in computing the milli-equivalent weight, you have to get first the molar mass, and then you have to correctly determine the equivalence factor. Huwag niyong kalimutan yung equivalence factor natin. You have to determine first whether the substance is an acid, a base, or a salt. If acid yan siya, the F is, bilangin nyo lang yung number of hydrogen. Pag base, you have to determine the number of hydroxide. Pero kung salt, either the positive or the negative charge. Okay? Once na na-determine nyo yung F, you can compute for the milli-equivalent weight. And then, gagamitin natin si milli-equivalent weight in the computation of normality. So do not forget, our unit here is MEQ per ml, or that is equivalent to capital letter N. Okay, questions for this? Kaya pa? Namahaw ba mo? Basig wala mo namahaw ha, tapos wala nag-sink in ang akong gipang istorya din hi. Kasi for your brain to function, kailangan niya ng sugar. Yeah, basig wala pa'y sugar, nan. Basig nag-abnormal firing na ato ang mga brain cells sayo pa sa buntag ani. Before we will proceed, nagsakit na yung gamitin yung reciprocal pag nasa ilalim yung unit. Okay, tapos meron siyang per. Okay? Wait lang ha. Lagyan ko lang ng non-share. Lagyan ko lang ng ano here before tayo mag-proceed. Ayan, I need a blank space. Let's practice. Practice tayo. Before tayo ano talaga ng normality, master muna natin si equivalent weight and si milli-equivalent weight. Ano sila kinukuha? So again, si equivalent weight, ginagamit natin siya kapag yung volume na binigay class is in liters. Please do not forget that. We use the equivalent weight if the volume na given is in liters. So how do we compute for the equivalent weight? This is molar mass divided by the F. Pag-determine ng F, kagaya pa rin ng kanina. Acid, base, or salt. Pag ang given naman na volume is in ml, and we are going to use the milli-equivalent weight. So ang kaibahan lang nila, yung F mo, i-multiply mo sa 1,000. So let's practice. Number 1, compute for both the equivalent weight of calcium carbonate. Again, we will be computing for both the equivalent weight and the milli-equivalent weight of our calcium carbonate. So ang una natin gagawin here, syempre mag-compute tayo ng molar mass. We cannot proceed with the computation without the molar mass. So calcium, carbon, and then oxygen. Calcium, carbon, and then oxygen. 1 atom for calcium, 1 for carbon, and 3 for oxygen. And then let's multiply each of them to their atomic weights. Calcium is 40. Please recheck that in your periodic table. Pakitingnan, 40, tama? Okay.
Yes, ma'am.
Sige, and then carbon is 12. So this is 12. And this is 16. So this is 48. 48 plus 12 plus 40 is 100 grams per mole. Okay? So unahin natin si equivalent weight. Equivalent weight is the molar mass. This is 100 grams per mole. And kayo ang tatanungin ko, ano kaya yung F ni calcium carbonate? Sige daw, kung nakuha ba yung sinabi ko kanina, you can send your answer sa chat. Ano kaya ang F ni calcium carbonate?
2 po, ma'am.
2. Okay. Let's see. May question mark, really sure. Okay. Calcium carbonate. Hindi ka makakakita ng hydrogen dyan. Wala din siyang OH. So, automatic salt ito. Okay? Salt si calcium carbonate. And then, you just check in your periodic table. Calcium belongs to group 2. So, ang charge ni calcium ay positive 2. Now, si carbonate is a polyatomic ion. Alam niyo naman na anong ibig sabihin ng polyatomic ion, di ba? Then, look at your list there. Carbonate is negative 2. So, positive 2 and negative 2 yan siya. Automatic, the F here is 2. So very good. That is correct. 2. And then take note, our unit for the F is, this is equivalent weight. Again, this is equivalent weight. So pag equivalent weight yan siya class, ang unit ng F is equivalent per mole. Okay? Yan yung unit natin ha kapag ka equivalent weight. Equivalent per mole. You will cancel the mole. And then let's divide. 100 divided by 2, that's 50. So, ang unit nito, grams per equivalent. Huwag mong baliktarin ha. Babaliktarin lang kapag ka merong per sa baba. Pero since kinancel natin yung mole, hindi siya babaliktarin. Grams per equivalent lang talaga yan siya. Okay? Ayan. So, that is now the equivalent weight of calcium carbonate. Now, how about the milli-equivalent weight? Yung milli-equivalent weight naman, molar mass, ganun pa rin, 100 grams per mole divided by the F. 2 pa rin yung F niyan kasi the same substance. 2 times 1,000. Ito lang yung pinagkaiba nila. And then ang unit. Since nag-multiply tayo sa 1,000 dyan, hindi na yan siya equivalent. Milli-equivalent na yan siya per mole. Yan yung difference nila ha. And then you cancel the mole. This is 100 grams divided by 2,000 MEQ. So this one is 100 divided by 2,000. Okay. 0.05. Okay, sulat ko. 0.05, the unit is grams per milli equivalent. Again, huwag magre-reciprocal kung wala kang per dyan sa baba. Meron yan dyan per like this one. Kung hindi natin ito kinancel, merong per sa baba, yun lang yung only time na babaliktarin mo yung unit. Pero pag wala, as easy yan siya. Grams per milli equivalent. So this is how class you compute for the equivalent and the milli-equivalent weight. Okay? Let me give you another example. Yung kayo naman yung magko-compute. Sundin niyo yung aking ginawa sa screen. Let me delete first this one. And then let me write the substance. This one. Okay, that is our substance. You compute for both the equivalent weight and the milli-equivalent weight. Then you send your answer sa chat. Dalawang answer yun. Equivalent and milli-equivalent. Okay, 63, 0.63. Okay, let's see. How do you call this chemical? Ang pangalan nito? HNO3.
Acid po, ma'am.
Nitric acid, ma'am.
Okay, very good. This is the nitric or the nitric acid. And nitric acid. So, before you can compute for both the equivalent weight and the milli-equivalent weight, you have to start first with the molar mass. So, nitric acid, HNO3, 1 for both hydrogen and nitrogen, and 3 atoms for oxygen. 1 for hydrogen, yung atomic weight niya, and then this is 14. And then this is 16. Okay, so 48 plus 14 plus 1 is 63 grams per mole. So yan yung gagamitin natin. Computation ng equivalent weight, 63 grams per mole divided by the F. This is an acid. So you just have to look at the number of hydrogen. So isang hydrogen lang siya, automatic yan plus ang F niya ay 1. Okay? So this is equivalent pala ito. Let We delete it. Equivalent per mole. Let's cancel the mole. Automatic 63 divided by 1. The equivalent weight is 63 grams per equivalent. Okay? So, ang isang equivalent daw ng nitric acid, ang weight niya is 63 grams. For milli-equivalent weight, ganun pa rin. Molar mass, so 63 grams per mole. Yung difference lang, multiply mo ito sa 1,000. And then, ang unit niya magiging MEQ per mole na siya. So, you cancel the mole. 63 grams divided by 1,000 MEQ is 63 divided by 1,000. This is 0.063 grams ang unit, grams per MEQ. Okay, so that's how we compute for both the equivalent weight and the milli-equivalent weight. Questions dito? Meron bang hindi naintindihan here? Yan ko kayo ng last one na. I would like to see if naintindihan talaga. Let me delete the writings on the screen. Siguro yung exam ko hanggang equivalent weight and milli-equivalent weight lang. Siguro hindi pa ako magbibigay ng normality na problem since isang example lang yung nabigay ko kanina. So dito muna tayo sa equivalent weight and sa milli-equivalent weight. Sige daw. You solve for both the equivalent weight and the milli-equivalent weight of aluminum oxide. 34? 34 or 0.34? Wait. Well, let's see. Sige. This one is called aluminum oxide. So before we can proceed, syempre, dun muna tayo sa kanyang molar mass. 2 atoms of aluminum, 3 for oxygen. Ano nga yung atomic weight? 27? Am I right?
27, ma'am.
Yes, ma'am.
ma'am.
Okay,
7.
27 times 2 is 54. This is 16. 48 plus 54 is 102.
102.
Okay, 102 grams per mole. Let's start with the equivalent weight. 102 grams per mole divided by the F. What is the F? Ang F nito?
3 po.
3, ma'am.
3? This is aluminum oxide.
Opo.
Ha?
2, ma'am.
Take note. Aluminum oxide is not an acid. It is not also a base. Wala kang hydrogen, wala kang OH. So dun ka sa charge. Ano sabi? Total number of positive or negative charge. Kung titingnan natin, class, si aluminum ganito. Aluminum ang charge niya positive 3. Tama? Positive
Yes, ma'am.
3.
Yes, ma'am.
Ilang atom yan? 2. So, positive 3 times 2, this is
6.
positive 6. Yan yung total niya. For oxygen, negative 2. Tama? Negative 2. Ilang
Yes,
atoms yan? 3.
3.
So, ang total niya, negative 2 times 3, negative 6. So, ano dapat ang F?
6.
6. Okay. The F class is 6. Okay? Nakuha? Bakit 6? Pinsay na libog. Di ba sabi ko kanina, i-total nyo siya. Tingnan nyo kung may subscript. Pag may subscript, i-multiply nyo. So 2 times positive 3, that's positive 6. Ito, 3 times negative 2, negative 6. Magpapantay talaga yan sila, class. Pag compound, magpapantay talaga yung positive and negative charges. As long as you have to make sure na nakuha nyo yung tamang charge niyan. Wait lang. Sulat ko siya. So this is 6. Our unit is equivalent per mole. Cancel the mole. 102 divided by 6 is 17. So the correct answer here is 17 grams per equivalent. Ganon din sa milli equivalent weight. 102 grams per mole. This time, 6 times 1,000. And then this is MEQ per mole. So you cancel the mole. This is 102 grams divided by 6,000 MEQ. The correct answer, 102 divided by 6,000, 0.017 grams per MEQ. Okay? So, ganon yung pag-compute. Nalito kayo sa 2 and sa 3. Remember, compound ito. Kapag compound class, magpapantay talaga yung positive and negative charges. You just have to multiply the charge to the subscript. Magpapantayan sila. And then, yan yung magiging F natin. So do not forget that. Siguro, when you computed, nalito kayo kung positive, kung 3 ba or 2 yung gagamitin ninyo. Do not forget na may subscript sa baba. Okay? Questions before tayo mag-end? It's already 8:58. So hanggang doon, class. Hanggang doon yung aking exam.